The thing robots are lacking at the moment is the ability to sense their own space and act on what's in their environment for a lot of objects. In other words, be able to recognise a lot of things that are currently around them and take action on those objects. The platform that the AR drone offers us has a lot of extra sensing capability. So for example, we have twin sets of cameras which we can deal with the images off, we can process the images, we can do a lot of object recognition and apply a lot of intelligence to those images that are coming in. We've got a lot of extra sensing on board, so we've got IMU data, we've got ultrasonic data, we've got barometric data, which gives us very high capability for these particular platforms. Within this room, what we're looking at is a spatialization problem. So we're starting from a situation where the AR drone doesn't know anything about the room at all. We initialize this map, and this is done using a process very similar to the way we use our eyes on the quadcopter. So it uses a pair of images to understand the depth and perspective that the room's around. So it picks out some key objects in the room, some just interesting objects, some little features, and it begins to build these into a map of the room, saying, well, okay, I know there are some objects in front of me. Because we've got this pair of images, that means we can understand how far these objects are away. And as the quadcopter begins to move around, we see that it begins to add to this picture of the room and build this bigger spatial map of the room. So we now enter an object recognition stage. So the quadcopter will move towards the front bench, and what it will begin to do is look for certain objects that it knows about. So for example, it will identify a book, and it will identify a power supply, it will identify the oscilloscope. As part of this process, we don't just identify these as objects and say, well, we know this object is in the room. We marry these two ideas together so that we can actually say, I don't just know this is an oscilloscope, I know this is an oscilloscope which is at this position. And not only is it at this position, it's at this position relative to my position because I can see both of them. So that what the quadcopter is doing is building this map where it knows where it is and it knows where every object is, so it can go close up to do further inspection. In the future, these drones are going to be particularly useful in areas where we can't send humans. So for example, in hostile environments or in friendly environments. So for example, in space or in the nuclear environment, we can't send a human in to go and control the robot in the environment it's going to be in. Therefore, what we need to be able to do is for the robot to understand its space that it's in and take those decisions itself. And using this technology we're developing here, we should be able to achieve this.
So here at Sheffield University, we are doing research about collaborative robots who are individually quite intelligent. They know about the environment as well as observe each other, and they can execute jobs like collectively exploring a nature disaster area, or surveyors can ask robots to inspect a building in detail, especially high-rise building or bridge structures or chimneys. There are lots of uses of collaborative robots. One of the things it can be used for, that robots can observe other robots, what they do. And without communicating about what they are going to do together, they actually can help each other by understanding what the other wants to do. So the other demonstration is about, when two robots meet and they have to pass each other.
The two robots will simultaneously take off, and they will identify their position in the room. The robots are initialized at the same altitude, and they have to accomplish their task, which is to go towards the wall that is in front of them.
We human beings don't find it necessary to actually talk to a person in the street how to go around each other, We smile when we do the same step at the same time to the side, and then change it and finally pass. So it's the same with robots.
Like humans, they should observe what the other drone is doing, and then if the other drone is in front of them, then they should change altitude. And if they change altitude together and go both higher, they cannot accomplish their mission. So for that reason, if you are using a learning algorithm, one is going in the high altitude, the other one will go to the lower one, and they will manage to cross.
We don't want robots necessarily to communicate about everything. It loads the network, it loads communications, it creates noise. So we want them to actually perceive the environment, accommodate other robots and humans in what they are doing. So I think this is an interesting challenge for the future.